Hello students, welcome to Narayan online classes. So, we'll start today's episode with the basic concept of chemistry. It is a first chapter in first PUC in part 1 textbook. In the board exam it carries 8 marks. Clear? So, what is the title of the chapter? Basic concept of chemistry. Okay. What is chemistry? Chemistry is a branch of science which deals with the properties, structures and composition of the substances. Mainly deals with properties, structure and composition of the substances only. Clear? So, in day-to-day life, majority of the things what you are using which is very close to the chemistry means in day-to-day life, chemistry plays very important role. So we have different types of the branches are there in chemistry: physical chemistry, inorganic chemistry, organic chemistry, analytical chemistry, biochemistry, bio-inorganic chemistry. These are different branches of the chemistry only. Okay, particularly chemistry is very important in pharmaceutical industries only. Okay, in the pharmaceutical industries, they want to prepare different types of the drugs which cure the diseases. Or suppose we are suffering with fever, or headache, or body pains, like this different types of the diseases. We want to prepare drugs. That preparation of the drugs requires mainly structure of the compound. So that includes what here chemistry only. Clear? If you want to see the treatment of the cancer, so cancer treatment generally we want to use cisplatin and Taxol. These are the two substances used for the treatment of which one? Cancer. And one more is there, AZT, that is azithromycin. And one more drug we have azithromycin. This will be used in the treatment of AIDS only. Not only these two important drugs, we have different types of the drugs are there. They can be prepared in the pharmaceutical industries. The applications are involved here related to which one means chemistry. Clear? So, introduction to this chemistry mainly we have talking about matter. The first important term we have to know, matter. Okay. What is matter? Matter means things which have space and occupy the things which have mass and occupy the space. We are calling as what? Matter. Things which have mass and occupy space. And occupy space is called as matter. So anything in the universe we can say easily it is a matter. Okay, suppose you are standing here. So we are having some mass and we are occupying some space only. So everything in the universe comes under which one here? Matter only. Clear? So based on the properties, based on the physical properties and chemical properties, matter can be classified into different ways only. Okay, so we have matter is there. This is the matter we have. Okay, matter can be classified into two important first categories. That is mainly physical properties, and one more we have chemical properties. In physical properties, matter can be classified into three different categories. Those are what here: solids, and one more we have liquids, and one more we have gases. Clear? Solids, liquids and gases. So chemical, suppose you can classify into chemical properties, mainly can classify into two important categories. Those we have mixers. Okay, mixers, and one more we have pure substance. Mixer and what more? Pure substance. Clear? Mixers again classified into two types. We have homogeneous mixture and classified into here, two important categories are there. Those are elements and compounds. Elements and compounds. So elements means you can take the metals, non-metals and metalloids. So you can take here metal, non-metal, and one more we have metalloid. So this is regarding about which one means classification of the matter. Matter we have base classification mainly based on the physical properties and chemical properties. Physical properties we have two classification, that is solids, liquids and gases. Chemical properties we have mixtures and the pure substances only. So mixtures again classified into two types, homogeneous mixture and heterogeneous mixture. Pure substance again classified into two different categories. Those are elements and compounds. So elements we have metals are there, non-metals are there, and metalloids are there. And the last one we have, which one means compounds. So here we have discussed what are the physical properties or the matter can exist in how many times in case of physical state, and chemical state what we have mixtures, pure substances. So homogeneous, heterogeneous, elements comes under metals, non-metals, metalloids, and compounds. We have to know each and every definition related to this classification. So here generally matter exists in three important physical states only. So what are the things here? Solids and liquids and gases only. So these three are the important physical states of the matter we have. So we have to know some of the properties which are related to solids, liquids and gases. Okay. So first column I make here solids, and next one we have liquids, and next one we have gases. Clear? So let us see the some of the points related to this three physical states. Solids, you can see this one. The first point regarding about here the structure of the solid, you can observe this one. This is the structure of the solid only. So in the solid the particles are very close to each other. So the particles are very close to each other. There is no gap present between two particles of the solids only. So in this case we can take the first point. Particles are very close to each other. Okay, particles are very close to each other. So this is the first point in solids. Okay. And you can see the point related to which one? Liquids we have. Clear? So liquids, how the arrangement of the particles we have. Clear? In liquids, the particles are not close to each other like solids. The particles are close, okay, close to each other. Not only very close, just close to each other. We say here particles are close to each other. Particles are close to each other. You can see in the case of here we have gases. So gases, you can see this one. The particles are far away from each other. The particles are what? Far away from each other. So we will see one more point here. Particles are far away from each other. Okay, so this is the first point which is related to which one here? Arrangement of the particles. How the particles can be present in solids, liquids and gases. Clear? Let us see here next point regarding about here attractive forces. Attractive forces. If you see the solid particles are very close to each other, so they have what here? Strong attractive forces. Strong attractive forces. So particles contain what type of forces? Strong attractive forces. Strong attractive forces. What type of the forces can be present here? They having some weak attractive forces. So So we will write here weak attractive forces. Weak attractive forces. In case of which one? Liquids. Come to this one, gases. When the particles are far away from each other, so what we can say? Attractive forces are very less. Okay, attractive forces are very less in case of which one? In case of gases. Come to we have third point over regarding about shape and volume. Shape and volume. So solids have different shape and volume, and solids have different volume and shape volume. Solids have definite shape and volume. So because the solid particles can be present in different shape volume, they can present in a different volume of the particular component. Come to this one, we have liquids. We have liquids. You can observe this one. Liquid have definite volume. Liquids have definite volume. They does not have definite shape. Why? If you want to pour the liquid in one glass or one bottle, they will get the shape of the container. So solids. What about liquids here? Liquids have definite volume. Liquids have definite volume, but not a definite shape. Why? You will get the shape of the container. Shape of the container. Come to this one. Third point we have. So gas molecules does not have different shape or different volume. So we can say this one, gas molecule does not have definite shape and volume. Definite shape and volume. So this is the third difference between solids, liquids and gases. Come to the next point, we have compressibility. What is meant by compression? By applying pressure, decrease the volume is called as compressibility volume. Let us see this one. This is a solid or liquid or gas. This is a solid volume. You want to apply some pressure. Is there any change in the volume? Is there any change in the size? No, because it is a solid. Solids, are not compressible. Solids are not compressible. So we can see here, solids are not compressible. Solids are not compressible. What about liquids? Liquids, you can say liquids can be slightly compressible, not highly compressible. You can say what? Liquids are slightly compressible. So liquids, you are saying here, liquids are slightly compressible. Liquids are slightly compressible. Come to the gases only. So gas molecules are far away from each other. You can apply some pressure. What happening here? You can apply some pressure. Volume increase or not? Here more gap is there. When you can apply the pressure, what happening here? The volume increases. Therefore, what you can say? Gas molecules are highly compressible. Gas molecules are highly compressible. So gases are, what you can say, highly compressible. Highly compressible. So these are you can say important differences between solids, liquids and gases. Solids, liquids and gases. Mainly these are what you can say, these are three important physical states of the matter. For example, you can take solids, you can take an HCl crystal, you can take iron, you can take liquids, water you can take, and bromine liquid also you can take. Gas you can take O2, N2 and H2. All these are examples for which one? Gas molecules. Next you can see this solids, liquids and gases. These three physical states are interconvertible. How they are interconvertible means we want to change the conditions like temperature and the pressure. If you want to say that increase the temperature or increase the pressure, these three physical states are readily interconvertible. by maintaining what conditions? By changing temperature and pressure. Temperature and pressure. Three physical states means what? Solids and liquids are interconvertible. Let us see the solids. Solids convert into liquids and liquids convert into what? Gases. So when the solids are converted to liquids means if you want to heat the solids, solids are converted into liquids. Again you want to heat these liquids, then what will happen here? Liquid is converted into gas. Clear? Now if you want to cool the gas, what will you get? Liquid only. Again you want to cool the liquid, what will you get? Solids. So that's the reason what you can say, when you are applying the heating is what? Temperature only. By changing the temperature, these three physical states are what? Radially interconvertible only. So you can take example here, ice. Okay, ice is converted into what here? Water only. Here water is converted into what here? Water vapor. Water vapor, we can say what here? Gas only. So what are the temperature we have to maintain here? Heat can heat the component. Heat of ice converted into water, water heat converted into water vapor, and water vapor cool you will get water, and water again cool you will get what? Ice only. So these are mainly what? Interconversion of one physical state into what? Another physical state. Generally at what temperature water is converted to ice means you can say at 0 degrees Celsius only. At what temperature water is converted to vapor, water vapor means at 100 degrees Celsius temperature only. So that we can maintain the temperature and conditions, we can convert that one physical state into another physical state by particularly what? By changing what? Temperature and pressure. So this is regarding about which one? Interconversion of the physical properties of the matter. Now this come to the chemical properties of the classification. Chemical properties of the classification, we have two are there. One is mixtures and one is what? Pure substances only. Let us see the first one we have. What is mixture? Okay, what is a mixer? Mixer is composed of two or more. Mixer is composed of what? Two or more substances which is present in a variable ratio. The ratio is not fixed, which is present in a variable ratio. Okay, mixer is composed of two or more substances which is present in a variable ratio. So this is the definition of which means here mixture. Mixture is composed of two or more different substances. Two or more different substances which is present in a variable ratio. Means the ratio will be the ratio is there. It is not a fixed ratio model. So what are example we can take here? If you want to make the mixer, you can make a sugar solution. You can make sugar solution. How can you prepare the sugar solution? We want to mix some sugar with water. You will get what? Sugar solution. Here, two or more different substances. One is sugar and one is what? Water. You can take this one. Okay. And one more you can take this one. Tea you can make. If you want to prepare the tea, what is required? Milk is required, tea powder is required, and one more what is required? Sugar also required. So we are mixing these three in what? Different ratios. What you will get? We can prepare what? Tea we have to prepare one. And you can take the third one, you can take here one more here. Salt water also you can take this. Salt water, it is composed of two different substances, that is what? Salt and water. If you want to mix these two, what you will get? you will get a salt water name. So this is regarding about which one mixture we have. Clear? Now the classification of mixture into how many types? Okay, mixtures again classified into two types only. The first one we have homogeneous mixture. Okay, the first one we have what? Homogeneous mixture, and the next one we have heterogeneous mixture. Okay, what is meant by homogeneous mixture? Very important definition is what is meant by homogeneous mixture. Okay, so homogeneous mixture we can define like this. Okay, the composition is same, or the components of the mixture is uniformly distributed. Throughout. That we are calling the what mixture? Homogeneous mixture. Components of the mixture. Component of mixture is uniformly distributed. Throughout. That so mixture you want to call it homogeneous mixture only. Components of the mixture is uniformly distributed throughout the solution. Or you can say if the two components can form, okay, and is present in uniform composition, that is also we are calling as which one? Homogeneous mixture only. So what are the example we can take here? Simply we can take here sugar solution. Sugar solution is also what? Homogeneous mixture. And we can take this one air. Okay, air is a mixture of which one? Different types of the gases. All the gases can be present in what? Uniformly can be distributed, but the percentage is a different one. Clear? Now we take this one salt solution. Okay, all the example which one? Homogeneous mixture. So last one I wrote here salt, water, sugar and solution, air, and we can add one more example also brass. Brass is an alloy. It is composed of copper and zinc. What is alloy? Alloy is a mixture of two or more different types of the metal. They are in homogeneous nature. Clear? Now come to the next concept we have heterogeneous mixture. So what is heterogeneous mixture means? The components of the mixture is not uniformly distributed throughout. The components of the mixture is not uniformly distributed. Throughout. So this is what mixture means. It is a heterogeneous mixture. It is heterogeneous mixture. So what are the example you can take? If you want to mix with the salt and sugar. If you take the sugar crystals and if you want to mix the salt crystals, we can mix together. Then what happened here? We can easily identify that both sugar particles and what salt particles. Clear? And we can make here pulses, grains, along with some mud particles. Okay. If you want to see the rice having some pulses is there. In that we can observe some of the grains are there. In some mud particles also there. We can identify that easily from this one. We can add one more here, sand with iron fillings. Okay, iron fillings mixed with sand, and easily observe that one that mixed sand and iron fillings are not uniformly distributed. You can easily observe that both sand particles and iron particles. And you can take this one sand water with the mud. If you want to take the sand water and with that one you can mix some of the mud there. So all these are concerned what type of example means here. Heterogeneous mixture means if you want to mix these two components, the components are easily visible for us. But in case of homogeneous mixture, you can see only one component because those solution can be uniformly distributed. The particles of the homogeneous mixture cannot be visible, but the particles present in heterogeneous mixture is what visible. Okay, we can take one more example also, milk also. How can you say milk is said to be heterogeneous mixture? Because we want to separate the cream from the milk one. If you want to do the churning and if you want to do the simplification process, the cream which is present in the milk can be separated. So we can see the separation of cream from the milk. So milk is comes under what example? Milk is comes under what? Heterogeneous mixture. Clear? Now we can see one important note. Okay. So generally, how can we separate the components of the mixture? So clear? The separation of the components of the mixtures, we have different types of the methods we have. Okay, hand picking. Okay, hand picking. By hand picking, we can separate the components of the mixture. And one more, the method we have filtration method is there. By using filtration, we can separate the components of the mixture. By using distillation, we can separate the components of the mixture. By using crystallization, we want to separate the components of the mixture. And by using chromatography, we can separate the components of the mixture. And these are the different methods we can see. And one more method also we can get sublimation. Sublimation also one of the method we can use to separate the components of the mixture. Okay, what are the different methods we have? Hand picking, filtration, distillation, crystallization, chromatography, and sublimation. These are the different methods are used to separate the components of the mixture. Mainly for which one? Separation of components. Separation of components from the mixture. Okay, so this is regarding about here types of mixtures and separation of the mixtures. Clear? So this is regarding about one of the classification of it. Again, these mixtures after one more what we have pure substances are there. Okay, and the next we have pure substance. Okay, what are the pure substances? Pure substances have a fixed composition. The consistent particles or the consistent atoms cannot be separated by physical methods. Physical methods. Pure substances have fixed composition. Fixed composition and the consistent atoms and the consistent particles are not separated by physical methods. Okay, pure substances are one composition, but they have a fixed composition, and the consistent particles are not separated by physical methods only. Clear? So if you want to take a copper you can take, silver you can take, iron you can take. These are the pure substances only. Okay. If you want to take the water, and if you want to take the glucose, H12O6. Okay. So these are the elements and these are the compounds only. If you want to take this glucose and water, okay, the components means what are the composition we have? It is composed of carbon, hydrogen, and what? Oxygen. Okay, the components cannot be separated by what methods here? Physical methods only. If you want to take the water is composed of hydrogen and oxygen. We cannot separate hydrogen and oxygen into what methods? Physical methods. This is regarding about which one? Pure substances. Now here the pure substances again classified into two categories, and one is elements and another one is compounds. Okay, what is is element. How can we define this element we have? An element is a pure substance. An element is what? Pure substance which is made up of one kind of atoms. An element is a pure substance. An element is a pure substance which is made up of one kind of atoms. One kind of atoms only. So here, if you want to take examples, generally, if you take here hydrogen and chlorine, you can take carbon, you can take oxygen, you can take, or aluminum, you can take, and sodium, you can take. So these are what here atoms only. These are what atoms. So generally, atoms are combined to form molecules only. Atoms are combined to form what? Molecules. We can take this one. Atoms combined to form molecules. Atoms combined to form molecules. Maybe same atoms are what? Different atoms only. If you want to take here H2, Cl2, O2, and N2. H2 you can take, Cl2 you can take, N2 you can take, and you can take this one carbon monoxide. All these comes under what we have. All these comes under what? Molecules. How these molecules are formed? Suppose you can take hydrogen atom and you can mix with another hydrogen atom, and both are combined to form one molecule. We have H2 molecule only. Generally, this concept is comes under chemical bonding. So, chemical bonding, one type of bond means it is a covalent bond. Here, sharing of electrons between the two atoms. Here, hydrogen having one electron, other hydrogen having one electron. So, the electron pair is shared between the two atoms. That bond we are calling is what? Covalent bond only here. Atoms are combined to form molecules. Maybe same atoms are what? Different atoms you can take will form the molecules only. Clear? Now generally, elements generally how many types we have is there? Generally elements we can take three types only. One is metal, and another one is non-metal. Okay, and another one is metalloid. Metal is there, non-metal is there, metalloid is there. So what are the examples for metal means you can take here? Sodium, potassium, copper, silver, iron. You can take all these are examples which are metals. You know the properties of the metals. Generally metals are hard in nature, metals are ductile in nature, metals are malleable in nature, metals are sonorous in nature. These are the different properties of metals you already know. Come to the next one, we have non-metals only. Okay, non-metal you can take this one, carbon you can take this one. Okay, and you can take oxygen. Like we have different non-metals. Nitrogen also there. Like this, you can take different types of the non-metals. So what are metalloids here? Metalloids you can take this one. Arsenic you can take. Antimony you can take here. Bismuth you can take. All these are examples of which one means metalloids. So these are considered what? Elements. Again we have three types are there. One is metal and one is what? Non-metal, and one is what here? Metalloid. So this is regarding about which one means elements. Okay. Next one we have which one means here compounds. Okay. So what is meant by compounds? Compounds is composed of two or more different elements. Two or more different elements. They present in what here? Fixed ratio. They present in what? Fixed ratio. Compound is composed of two or more different elements present in a fixed ratio. Okay, that we are calling here compound. So compound is composed of two or more atoms of different elements combined together in a different ratio. They may be present in a fixed ratio based on the composition, or in a different ratio. What we are getting the compounds. Compound is composed of composed of elements combines with the different ratio. Okay, compound is composed of two or more different element combines what na different ratio. The molecule of compound is obtained. The molecule of compound is obtained. So this is what definition of which one compound of. So what are the example you can take here? You can take the example here H2O and NH3, and you can take here SO2, and you can take here H2SO4, etc. We can take this one. Okay, so these are examples for the compounds. Clear? So let us see the example here how the formation of water will be takes place. Okay, if you want to prepare the water here, water can be formed like this only. H2 plus O2 gives rise to H2. H2 plus O2 gives rise to what? H2O. Here you can write here 2H2O gives rise to 2H2 plus O2 gives rise to 2H2O. Let us see the properties of elements. Okay, before the formation of the compound. Okay, before the formation of the compound, hydrogen gas having some properties, oxygen also having some properties. But after the combination of these two elements, what is formed here? Water is formed. Means what here? The properties of the compound is different from the properties of the elements what are used in the chemical reaction only. Here H2 gas, generally H2 gas burns with pop sound. It gives a pop sound. Means what here? It burns with pop sound only. What is the nature of the oxygen? Generally oxygen is a supporting for the combustion. Supporting for the combustion. What is the nature of the water? Water can be used as a fire extinguisher only. Have you understood the difference here? H2 burns with the pump zone. O2 is the supporter of combustion, but water can be used as a fire extinguisher. Means what here? The properties of the elements is different from what? Properties of the compound. Means what here? The properties will be changed after the formation of each one compound. Clear? So the next one we have properties of the matter and their measurements. Okay, matter have two important properties. The first one we have physical properties. The first one we have physical properties. Okay, what is meant by physical properties? The properties can be measured without changing the composition of the substance. Okay, the properties which can be measured, the properties which can be measured by, the properties which can be measured by without changing the composition. Without changing the composition of substance. Okay, so the you can see which of this. It is having some color. It is in white in color, or you can say colorless only. So it is having some order. It is having some smell is there, and it is having a particular some centimeters of length is there, and it is having some width is there. Okay, these properties can be measured by observing the substances only. Clear? So what are the physical properties means here? The properties can be measured without changing the composition of the substance. Okay, what are the properties comes under these physical properties? You can see here. You can see that color you can see, order you can see, melting points you can see, and boiling points you can see. So all these properties comes under what properties you can say? All these comes under which properties? Physical properties only. Physical properties. We can see here density also. Density also we can take this one. Clear? And the second one we have chemical properties only. Chemical properties. So what are the chemical properties? Means the properties which can be measured by chemical reaction. by observing the chemical reaction. The properties which can be measured by changing the composition. By changing the composition by what reaction? Chemical reaction is called as what properties? Chemical properties only. The properties can be measured. The properties which can be measured by changing the composition. How we can change the composition? The composition can be changed by what? Changing the composition by chemical reaction. By chemical reaction. If you want to do the chemical reaction, what are the changes you can observe is here? We can take the examples like this here. Acidity, and we can take this one basicity, and one more we can take this one combustibility. Okay, so these are what properties? These are we can observe when the chemical reaction takes place. So these properties we are calling as what? Chemical properties. Acidity. Okay, basicity. Acidity we are using for the bases. Basicity we are using for the acids. And combustibility means what? Complete burning of the substance. Suppose we want to do, what are the change in the physical properties? Okay, there. So these are what here properties of the matter. One is physical properties and one is what? Chemical properties. Now we can see the measurement of the matter. The measurement of the matter, we can use different types of the units only. But entire the world they are following one system of units that is called international system of units, that is we are calling as a SI units. SI units we are calling. Now we can see base physical quantities and the units only. SI units maximum we are using only. So we have here different types of the physical quantities are there. What is the symbol for quantity? What is the name of that SI unit? And what is the symbol for SI unit? You can see. The first one you can see here, length only. Okay, length. Okay, what is the symbol for quantity? Generally, we are using here L only. What is the name of this SI unit? Means here this is a meter, and we can take this one what? M is the symbol of which one here? SI unit. So now here we can take this one mass. Mass we are taking here M only. What is the SI unit of mass? Means it is a kilogram. And we are taking what here? kg only. Okay, the first one is there, and second one is what? Mass. Okay, and the third one we can take this one current. Okay, current generally we have denoted by I only. So what is the essence of this current? Means here ampere. Okay, the unit of this ampere is a symbol, you can write A only. Okay, and the next one we have temperature. Okay, temperature only. So temperature generally we have three different types of the scales we have. Okay, temperature we have how many scales we have? Means three different scales we have. One is generally temperature means capital T we are writing here. So what is the S unit of this one? Means we have Kelvin, and we can write here K1. Clear? Now we can take this one time. Time we are taking. So time generally means here small d. So generally how the time is measured we can here. The measures in what? Seconds only. Time is measured in what here? Seconds. We can take the symbol here S only. Okay. So now we can take the one more here, amount of the substance. Amount of the substance. Amount of the substance generally denoted by here small and only. What is the name of SI units? Means here mole we are taking, and we can take here mole, M-mole we are taking. Okay, and we can take here luminous intensity. Okay, we can take here IB. This is a candela we are taking. What is the symbol of this element? Means C4. So this is regarding about which one here? Basic physical quantities and their units here. 1, 2, 3, 4, 5, 6, 7. These are the main basic physical quantities and their units only. Mainly can concentrate on whole year for account of the substance. Intensity we have candela, at the time we have seconds, temperature we have Kelvin, current we have ampere, mass we have kilogram, length we have meter. Now we can see some of the prefixes used in SI system. So the prefixes can be present like this: 10 power minus 1. 10 power minus 1 in following and we see represented by d only. 10 power minus 2 centi c. 10 power minus 3 milli m. 10 power minus 6 micro, this is mu. 10 power minus 9 nano n. 10 power minus 12 pico and p. 10 power minus 15 femto and fo. So these are important for us from up to year 1 year. 10 power minus 1 to 10 power minus 12, minus 1 deci, minus 2 centi, minus 3 milli, minus 6 micro, minus 9 nano, minus 12 pico. These generally we are using in the unit conversion, but the remaining information also we have to know. 10 power minus 15 femto, that is F. 10 power minus 18 alto, that is A. 10 power minus 21 zepto, that is Z. 10 power minus 24 yuto, that is Y. 10 power 24 iota, Y. 10 power 21 zeta, Z. 10 power 18 hexa, E. 10 power 15 beta, P. 10 power 12 tera, G. 10 power 9 giga, Z. 10 power 6 mega, M. 10 cube kilo and kg. 10 power 2 hecto, H. 10 deca and D. So these are main, what means these are main prefixes used in the SI system of the units. Next we can see the definition of this mass. What is mass? Mass of the substance is amount of matter present in it. Mass of the substance is amount of matter present in it. This is called as mass. Now we can see the one more definition also we have weight only. Okay, how can you define this weight of the substance only? Okay, weight of the substance we can define. Weight of the substance is force exerted by gravity on an object. Gravity on an object only. Weight is force exerted gravity on a object. This is called as weight only. What is the difference between weight and mass? Means mass is constant only. Mass is always constant. Mass is constant, but the weight really changes from place to the place only. Weight changes from one place to another place. One place to another place. Why? There is a change in the gravity on different types of the places. So there is a change in the weight of the substance, but the weight of the mass of the substance is what? Constant. So what is the SI unit of the mass? SI unit of mass. SI unit of mass is equal to what? Kilogram. SI unit of mass is what? Kilogram. So if we write here 1 kilogram, 1 kg is equal to how many grams? Means you will write 1000 grams only. From this we can write here 1 gram is equal to 10 power minus 3 kilograms. So these units are very important for us. I think you understood. 1 gram is equal to 1 by 1000. 1 by 1000 means how much? 10 power minus 3 kilograms only. This is regarding about which one? SI unit of which one? Mass only. Okay. Now we can see the next one we have volume. Okay, how can you define this volume? Volume is the amount of space occupied by the substance. What is volume? Volume is the amount of space occupied by what? Substance only. How can you measure this volume? Generally, length you are taking on. Okay, if you take the units generally, what you can take in units is equal to length whole cube. You will take the height to breadth you are taking. We are taking what? Length whole cube. So generally, what is the SI units of volume you are taking? SI unit of volume. That is equal to, generally we are taking as meter cube only. We are taking meter cube, but meter cube is a big unit only because we want to calculate the volume in very small units only. The small units we are taking the volume generally in the form of which one? Centimeter cube we have taken. Meter cube is a big unit only. We have to measure the volume in one for in the chemistry laboratory with the titrations and all, we can measure the volume generally, okay, in the form of which one? Centimeter cube volume. So generally, what is the common unit of volume? The common SI unit. Common SI unit of volume, okay, is equal to liter we are taking on. This is the commonly we are using what? SI unit what? Liter only. From this you are writing here 1 liter is equal to 1 liter is equal to how much means here 1000 ml. 1 liter is equal to 1000 ml. From this you are writing here 1000 ml means I am writing here 1000 centimeter cube because 1 ml is equal to 1 centimeter cube. 1 centimeter cube. So 1000 centimeter cube means you can write here 1 decimeter cube. So these are what here different conversions of which one? Volume. Volume can be expressed in liter, volume can be expressed in milliliter, ml, and volume can be expressed in centimeter cube. Volume can be expressed in what? Decimeter cube. Okay. 1 liter is equal to 1000 ml. 1000 ml in the sense 1000 centimeter cube, that is equal to 1 decimeter cube. Okay. This is regarding which one? SI unit of which one? Volume. Now we can see the next one. We have density. Okay. What is meant by density? Mass of the substance present per unit volume is called as what one? Density. Mass of the substance present per unit volume is called what one? Density. Density D is equal to, generally we can say density D or also using density D is equal to mass by volume. Mass by volume. If you want to write a density with SI units, okay, what are the SI unit of mass? Kilogram. And what is the SI unit of volume? Meter cube. From this you are writing here kg per meter cube only. So density D is what are the units you can? Density is units in what? SI form. We are writing kg meter power minus 2. But these units are very high units, so big units we are using. So if you want to write in a single units, what you can write here? Density units you can write here gram per centimeter cube. Gram per centimeter cube. This is regarding what which one? Density. Okay. The next one we have temperature. Temperature. So how can we measure this temperature? Means the temperature can be measured in 3 different scales. Okay, one is degrees Celsius, and one is Fahrenheit scale, and one is what? Kelvin scale. So very important and very easiest conversions only. We can convert this degrees Celsius into Kelvins, or Kelvins into what? Fahrenheit. So vice versa, we have to convert this one. We have how many scales? We have temperature can be measured in what? 3 different scales. 3 different scales. The first one we have degree Celsius. Degree Celsius. So we can write this one degree Celsius. And the next one we have Fahrenheit scale. So we can measure in 3 different scales. One is degree Celsius and one is degree Fahrenheit and one more we have Kelvin only. So these units are conversion either for the Fahrenheit to Celsius scale or Celsius scale into what? Fahrenheit scale. What is the formula we have? F is equal to 9 by 5 Celsius plus what? 30 to 1. From this you can write one more formula. C by 5 is equal to F minus 32 by 9 also you can write. Okay, what is C? Degree Celsius. And what is F? We have Fahrenheit only. So we can convert these formulas in interconvertible. We can convert into Fahrenheit into Celsius or Celsius into what? Fahrenheit only. So how can you convert this Kelvin scale only? Okay, Kelvin scale, suppose you can take this one. If you want to convert the Celsius into what? Kelvin. Okay, so we can write here Kelvin scale K is equal to Celsius plus how much you can write there? 273.15 you can take over. For our calculation convenient purpose, we are how much we are adding this Kelvin scale is equal to so degree Celsius, 0 degree Celsius, or you can say this one degree Celsius plus how much you can write 273. This scale we can use for what purpose? Means we can convert this Kelvin scale to Celsius scale or Celsius scale to what? Kelvin scale you can take. Suppose you can take this one 27 degree Celsius. 27 degree Celsius is there. How can you convert them into Kelvin scale? Now Kelvin scale, what is the form we can use here? Celsius scale plus what? 273. Here 27 plus what? 273. How much you are getting? We have to get 7 plus 3 10. Total you will get 300 Kelvin. 300 Kelvin. Like this we can do different types of the calculations. So this is regarding to which one? Temperature.